quantity. Very simple. Remember, anything that can be measured, anything can be measured is a physical quantity. Let me write this down here. Anything that can be measured. What are the examples of stuff that you can measure? What is this anything here? We are talking about the characteristics of objects. You see, some object, they are small, some object, they are big. There is a characteristics of object here. We are talking about the size of object, some small, some big, some short, some long, some thick, some thin. These are the characteristics of object, right? So we give it a name to all these characteristics. For example, short object and long object. What is the characteristic called short and long? We call it length. We give it a name, we term it as length. Okay, so we are talking about characteristics of object. The first one we have is length. So length is a characteristics. How long, right? Short, long, something like that. Now, if I say that an object is big, how big can you measure? Because big is like very general, right? How big is it? You want to be able to measure it. Okay, so that is the size. Okay, and if I say that an object is very heavy, how heavy is it? You want to be able to give it a number. How heavy is it? 5 kg? Is it 10 kg? Okay, you want to measure it. So you need a quantity, you need a physical quantity. What is that physical quantity when we say that object is heavy or light? What is that physical quantity called? Again, we give it a name. The name is mass, right? Mass. How heavy is something? So we have our second physical quantity. Notice that I can measure length and I can measure mass. So both of these, they are physical quantity. It is something that I can measure. Now, there is one more where I run the jogging track 100 meters in 15 seconds. Another person, he runs the jogging track, the same track, but he can complete it in 10 seconds. What is the difference between these two? What is that characteristics that is different between these two persons? It is the one can complete in 15 seconds, another one complete in 10 seconds. So there is a characteristics of time involved here. Okay, one can complete in a shorter time, one can complete in a longer time. So the difference here is the time. Again, we put time in our list because time is something that we can measure. Okay, so now our list have 3 physical quantity already. Can you think of any other physical quantity that you can add to the list? 还有什么是可以量的? If you talk about motivation, can we measure motivation? If I feel like I'm motivated, how motivated? Can you measure it? I'm 5 cm motivated. That doesn't make sense, right? I'm happy. How happy? How much? You cannot answer that. How much happy, right? I'm 10 cm happy. No, there's no such thing. So happiness, motivation, they are not physical quantity because you cannot measure it. Okay? You see the difference, huh? So now, length, mass, time. What else? Just think of something around you. Okay. First, we think of, okay, distance. Distance, can we add into our list here? Distance. Now, if you think of distance, right? Distance is什么? Distance is measure of length. The same thing, right? You measure distance using length. What about area? How do you measure area? You measure area using, okay, length times width. Length times width, correct? Again, what is width? Width is also a length. This is length. We can also say is length times length, correct? So at the end of the day, whether it's area, volume, or distance, you are still referring to length. At the very base, at the very fundamental, it is all related to length. Okay, so let me write it here. Distance, area, volume, 这三个都是 length 形成的。Okay, this one you have length times length. This one you have length times length times length. Distance is also a length. So this three, do we include in the list? No, because it's the same thing as length. So I just stick to length. Still, we put this three in the, only this three in the list. This three, we do not add into the list. Okay, because they are just the same as length here. Okay, now one very important thing, you see, this length, if I ask you what is area, you can answer area is length times length. But what if I ask you what is length? What is length? Length is just length, right? So that means you cannot explain it anymore, right? So length is just length, and you cannot use length to explain mass. They are not related. You see, you cannot say 3 meters of sugar. Can you take 3 meters of sugar? No, it doesn't make sense. If I say, can you take 1 gram of sugar? Yes, that makes sense. Okay, because I'm talking about the mass. Can you take 1 gram of sugar for me? Yes. If I say, can you take 3 meters of sugar for me? It doesn't make sense. That means you cannot use length to define mass. Okay, you cannot use length to define mass. Or I can say that here, mass cannot be expressed in terms of length. Okay, because they are totally different. One cannot be expressed by another. You also cannot use length to explain time. Okay, so they have to be separated. They have to be one single thing. Okay, so all this, what do we call it? All this, we call it the fundamental quantity. Please remember this, fundamental, or we can say the base quantity. Okay, the most basic. You cannot break it down anymore. Area, you can still break it down. Area, you can break it down to length and length. Can you break length into smaller pieces? No, it's just at the very base is just length. So this quantity, we call them fundamental quantity or base quantity. Okay, so first thing is this fundamental quantity. So how do you explain fundamental quantity? It is any physical quantity that cannot be broken down further. Okay, something like that. Now, other than the base quantity, what do you have? You have derived quantity. Derived quantity. What is the meaning of derived? Derived 的意思就是你从这里拿到这个。Okay, you get this from something else. You derive something from another thing. Okay, so derived is like area, volume, all this, because you derive. How do you derive area? You derive it by using length multiplied by length. That's how you get area. So you derive area from length. You're combining the base quantity to form a new quantity. Okay, so you are combining length and length to form a new one, area. You combined length and length and length to form a new one, volume. What else? You combine length and time. What do you get? Distance. Okay, you combine distance and time. Distance is length, right? So you are combining length and time. What do you get? You get speed. Okay, you get speed. So speed is also a derived. Okay, so you see all this, right? Area, volume, and speed. You can get it from the combination of either length, mass, or time. We call them derived quantity. You can think of it like the periodic table, the element in the periodic table. H2O. How do you get H2O? You have hydrogen and you have oxygen. Okay. Hydrogen is like the base quantity. Oxygen is also the base quantity, but your H2O is the derived quantity. Okay. This is hydrogen is already the simplest. You cannot break it down any further. So you can combine with oxygen, you get a new one. You get water, H2O. That's derived. So it's like I can combine length, I can combine time, I get a new one. I get speed. Okay, understand? Make sense? Okay, so we have two types, fundamental quantity and, more commonly we call it base quantity. So we have base quantity and derived quantity. This is the first grouping of physical quantity. The first classification. Now, other than these two, we still have another group, another classification of physical quantity that we call it the scalar and the vector. Now, let me write it down here. First classification. Okay, let me just put it like this. First group. We group it based on base and derived, right? And second group, we group it based on scalar and vector. Okay, what is scalar and vector? Scalar is magnitude only. I want you to remember this, magnitude only. And vector is magnitude and direction. If I'm going too fast, let me know. 跟我讲如果我太快还是你要我 repeat 什么？Let me know in the chat. Okay, so the scalar is magnitude only. 什么是 magnitude? Magnitude is like how big is something, the value of something. Like for example, earthquake. You have heard about earthquake. 6.0, 7.0, 8.0. That is magnitude. Okay, the size of something. If I talk about speed, 4 meters per second, 5 meters per second, or 20 meters per second. What is all this? This is magnitude. Okay, so 20 meters per second is, it has the highest magnitude. It can be applied to anything. You talk about force, 5 Newton, 10 Newton. Which one higher magnitude? 10 Newton higher magnitude. Okay, 所以你可以把它想象成那个value， 那个 value 是代表那个 magnitude。所以 scalar 只是 magnitude and vector 是有 magnitude 跟 direction。OK， 我给你一个 example。Let's say 我讲 force 啦 ，OK， 我讲 force， 我们可以算到 force 吗？可以 measure force 吗？可以。所以 force 是 physical quantity。OK，because anything that can be measured, so we can measure force. Force is a physical quantity. Now, 如果我教你 let's say 我讲 please apply a force on this pen. Okay, please apply a force on this pen. Your next question would be where? Where you want me to apply the force? Like in what direction? If I say please push the pen, where do I push it? Do I push it from here? Do I push it from here? Do I push it from here? Okay, so you see here what is missing. The one that is missing is the direction. If I say, please push the pen to the right, Then you understand. Then you apply the force, push the pen to the right. If I only say, please push the pen, you don't know where to push it. So the information is not complete. Okay, you did not fully understand my statement because the information is not complete. 不完整的一个information. Okay, 所以 force we say force must be a vector because you need magnitude, which is how much force, and also you need direction. Okay, if I describe it to you, please push the pen with 4 Newton force to the right. Here I'm giving magnitude, 4 Newton, and I'm giving direction to the right. You understand it, and then you apply the force. So force is a vector quantity. You have to give it a direction to make sense. Let me give you another example, okay? You see, position. When we talk about position, if I ask you to describe your position, how do you describe your position? Just think of it. How do you describe your position to me? So that in a brief sentence, I know exactly where you are. How? You will find it a bit difficult, right? How do you describe your position, your current position, so that I know where exactly you are? If I say my current position is 5 km from the KK International Airport. Do you know my location? If I just say I'm 5 kilometers from the airport. You don't know, still don't know. Why? Because even if you know where is the airport, you measure, okay, 5 meters, is it 5? Okay, 5 km, is it 5 km to the north, to the south, to the east? Where is it? You can draw a circle around the airport with a radius of 5 kilometers. I could be anywhere inside the circle. Okay, again, the information is not complete. What should I say? I am 5 kilometers to the south of KK Airport. Then you take a map, you see where is the airport. Okay, this is the airport, and then you see, okay, to the south of the airport, you measure 5 kilometers, you make a mark on the map. Okay, this is your location. You can pinpoint my location exactly. So, is my information complete? Yes. What am I giving here? I'm giving magnitude, 5 km. I'm giving direction to the south, to the north. Is it not to the south of the airport? Again, 2 things is there: magnitude, direction. So, whenever you describe position, you have to give magnitude and direction. If you don't give the direction, nobody can find you. If I say that, okay, please help me get my motorcycle. Please help me get my motorcycle. I park at 500 meters from here. What is your next question? Where is it? Right? I give you the magnitude. Help me get my motorcycle. It's 5 meters from here. You will ask me, where is it? Which direction? You see, okay, the direction is missing. Okay, so again, I have to give the direction. So position is a vector quantity. Okay, it is a vector quantity. So position and force both are vector quantity. They need magnitude and direction in order to make sense. Okay, what is an example of a scalar quantity? Scalar quantity no direction. For example, like time. What time is it? Okay, now it's 8 o'clock. Can I say now it's 8 o'clock southeast? Doesn't make sense, right? Because time has no direction. You know, you don't need to give direction. Time is just time. How fast are you moving? I'm moving at 5 meters per second. That is speed. Okay, you don't need to give any direction because I'm only asking for your speed. How heavy is it? 5 kilogram. Can I say 5 kilogram to the north? No, doesn't make sense. So direction, we don't need to give direction. These are example of scalar quantities. Okay, so scalar quantities is you have speed, you have mass, you have time. What else? There are many, right? You have temperature. Okay, what is the temperature? Okay, 27 degrees Celsius. You don't need to give directions. Only magnitude, it makes sense. So these are the only two classification of physical quantity. Okay, and you need to know because always they will ask, is this scalar, is this vector, is this base, or is this derived? Okay, next slide we'll go to another slide that we will see what are the common physical quantity that we will study in physics. Okay, so if you want to like take a screenshot or anything, you can do it now because I'm going to erase this one. Okay, you should be seeing my worksheet with tables. So these are the few common ones. You need to remember the 5 base quantities. What are those 5? You can see here length, mass, time, temperature, and electric current. Okay, and what is base quantity again? It is the simplest form. You cannot break it down anymore. Temperature is just temperature. Okay, so in physics, the symbol is very important. You have to remember the symbol also. What is the symbol here? Usually we take the first letter of the quantity lah. So length, we just take L, mass, we take M, time is T, and temperature is capital T. Time, we take smaller t, lowercase t, and electric current is actually I. This is I. You write I. The length is L and electric current is I. Right. Now, and then we have the unit of the quantity. Let's start with the length. What unit do we use? What is a unit? What is a unit? You see, in the early days, 以前的人 okay, 他们怎样做 measurement? How they make measurement? If I say that this is 1 inch, have you ever questioned why is this 1 inch? Why not like this? Why not like this? Why this is 1 inch? Right? You see, if I say that this is 1 inch and I tell everyone, okay, this is 1 inch, everyone agree with me. They said, okay, I agree with you. This is 1 inch. If everyone agree with me, then this become a standard measurement. Okay, write it down. I write it down here. It become a what? Standard measurement. It becomes a standard. It becomes a standard measurement. A standard measurement is a unit, which is something that everybody agree. No one will question it. Everybody agree. If you agree this is 1 inch, then everybody agree this is 1 inch. This is what happened back then. Okay. Now, how do I make measurement with this? I will take, okay, this is my 1 inch, right? If I want to measure how long is this, then I will put like this. Okay, 1, 2, 3, 4, 5, 6. 6 of this, then I will call this 6 inches. This one. Notice that how I measure here. I'm seeing that how much of this one can contain. 6 of this, then I will call this 6 inches. Okay, so I'm taking measurement based on my unit. You have different unit, right? Another example, if I say, okay, this is 1 kg, this one, 1 kg. Is this really 1 kg? If you agree, everybody agree, then this is 1 kg, right? So if I say that this is, I declare to everybody, okay, this is 1 kg. Then everybody take this, they put it on the beam balance. Okay, 他们放在一个称, and then 他们放这样子. Okay, this is my 1 kg. And then they make many sample of it. They put other objects like this. Okay, this is their sample until it balance. Then they will call it, okay, this is also 1 kg. Okay, they are creating, people, they create a lot of sample, a lot of replica of my 1 kg. And then they take this, now they remove this, they say, okay, this thing is 1 kg. Now, if I want to know how heavy is this one, how do I know? Then I will put it on a beam balance. I put it on a beam balance, and then I will put my sample here. This is my sample. I stack it up. I put 1, I put 2, I put 3. Okay, 3, now it balanced. How heavy is this? Then they calculate, okay, 1 kg, 1 kg, 1 kg. That is 3 kg. Then they call this 3 kg. Okay, so what they are doing here, they are measuring using comparison. So measurement is all about comparison. You are comparing one to another. Okay, so here, what is my unit? My unit is kg, kilogram. Just now, my unit is inch. These are the unit that is agreed by everyone. So a unit, how do we define it? A unit, we call it a unit is a standard measurement. A standard measurement, let me write it here. Measurement that is, a standard measurement of a quantity. That is agreed by everyone. Okay, so write this down. Only this sentence. A unit is a standard measurement of a quantity that is agreed by everyone. What is the quantity here? The quantity is the physical quantity. For example, like mass. If my quantity is mass, what is my unit? My unit is kg. So a unit is a standard measurement of a quantity that is agreed by everyone. So measurement, right here, measurement of an object is comparison with my standard unit. Just now, the 1 inch. I take measurement of this. I compare how many of this? 6. This is 6 inch. So I'm doing what? I'm doing comparison. Measurement of an object is comparison with the standard unit. Okay. Can anything become a unit? 我可以随便拿一个东西做成 unit 吗？你看啊 ，let's say a person want to sell clothes in a village. Okay, somebody come and ask the person, can I have 6 hands of clothes? 6 hands. 1 hand, because in the early days, right, sometimes they use hands to do measurement. Can I have 6 hands of cloth? Okay, then the person take the cloth, they measure, okay, 6 hands, 1, 2, 3, 4, 5, 6, then they cut, then they give it. Okay, so what is the unit here? The unit is hand. 1 hand, 2 hand, 3 hand, 4 hand. Okay, and by the way, that's how you get the feet, right? 1 feet, 2 feet, 3 feet, 1 foot, 2 feet, 3 feet. Okay, so now, is it reliable? Is it practical? Not very practical. Because why? Because hand, right? Some people, they have longer hand. Some people, they have short hand. Okay, so it's not reliable. What if I give you a cloth that has 100 hand? That is 100 hand long. And I ask you to sell it to 100 people. Okay, I give you a cloth that is 100 hand long. I ask you to sell it to people, sell it to 100 people. If you sell it to people with longer hands, then you only can sell about maybe 95. Because by 95, your clothes already finished. Okay, you can't even sell it to 100 people because you have different sizes. You sell it to only people with long hands, right? So is this a reliable unit? Can we take this unit? Can it become like a real unit? Cannot, right? Because it keeps changing. Okay, it keeps changing. So when you pick a unit, it has to be something that is fixed, cannot be changing. Okay, so that is how they pick all the units. Now you see yards, cm, meter, kilogram, all this unit that you see. And we sometimes use feet, okay, 1 feet, 2 feet, something like that. Okay, so in other words, we need to have a rigid meaning of unit. Okay, now you see, there's one problem. There's one problem back then in the old times. Okay, so people can create standard unit. If I say this is 1 kg, then everybody believe, everybody agree. In this region, in this country here, if in other region, in other countries, they can have their own unit, right? They have their own unit. That's why you have cm and meter and yards. Okay, you have different unit of measurement because back then all these scientists, they form their own units. The French and the British, okay, the French and the British, they have their own unit. They don't want to use other people's unit. I don't want to use your unit. I use mine. Okay, so the French back then, what they use, the French people back then, when talking about length, let me write it here, length. The French, they use cm. Okay, they say, okay, I'm going to choose cm as our unit for length. And for mass, the French people, they use gram. And for time, they say, I want to use second. But then other regions like the British, They say, okay, I'm not going to use cm, I'm going to use my own unit. I'm going to use this foot. How about mass? They use pound. 1 pound, 2 pound, 3 pound, right? And then time, okay, same lah. This one use second. Okay, so different standard unit they have. Now, this create a problem. This create a problem. What problem? Because we are different, we are using different unit, right? So if I want to share let's say I want to communicate with other people in other countries, but we are not using the same language. How do we communicate? If I want to share my result, like I do a scientific research, I share my result, I want to publish, but you cannot understand because we are using different unit. That is the problem created back then, right? So what happened is that they have to come together and form a common language. They have to share one common language. Okay, I speak Malay, you speak Chinese, we cannot understand each other. We have to come to a common language. So in the unit industry, okay, they have to form one common language that they call it the International Standard of Unit. Okay, International Standard. Standard of Unit. Short term as SI unit is what you see up here in the column, this one, SI unit. What does it stand for? International Standard of Unit. You see, standard unit, you know, but I put an international in front. That means globally, everybody agree. The scientists, they all come together in a meeting room, they sit together, and then they decide, okay, which one we are going to use. They have to do that. They had to do that because, especially with business, global business, airline, you fly from one country to another country, you must communicate, right? So airline industry, with this industry growing back then, they are forced to come up with the International Standard of Unit, the SI unit. Okay, so now today we use the SI unit for all the physical quantities. You see, length can have many units. You got cm, you got meter, you got inch, you got feet, you got yards. So many, right? You got millimeter, you got kilometer, you got nanometer. So many units. Which one we are going to use? We only pick one that we call the SI. So the SI unit for length, we are going to use meter. Okay, so meter is the SI unit for length. So that anything that I calculate, in the end, I make it become meter. If it's not meter, I convert it become meter so that other people can understand. Okay, so that is the meaning of SI unit. Please remember that. Okay, it's like SOP, right? You have this whole COVID thing. 你去到哪里，你就要跟这个 SOP。OK， 同样的东西，你什么 unit， 你 length， 你就要跟这个 SI unit meter。OK so let me erase this erase this. And we are going to fill in the SI unit for each physical quantity. After that, I will give you a short break. Okay, a short break, then we'll come back. Okay, so the first one, length SI unit 是什么 ？SI unit meter. Meter 我们写它的名字在这边，这个是 name。然后 unit 自己也是有 symbol 的，它的 symbol 我们也是拿第一个 letter 就是 M 啦。OK， 第二个 mass。What is the SI unit for mass？ 你有 gram， 你有 kilogram， 你有pound， 所以我们选哪一个？我们选的是 the thing that they decide is kg， kilogram。 kilogram, kg. Okay, next one, time new hour, minute, second, year, day, month, 全部都是 unit time 的 unit 对吗？我们的 SI unit 是 second。OK， 所以当我们做 calculation 的时候，如果有算到 time，question 叫我们 express in SI unit， 你就一定要给 second。Okay, second, so S. Right, next one, temperature. This one is special a bit lah. This one is Kelvin. We don't use degrees Celsius. We use Kelvin, capital K. This is capital K, Kelvin. Okay, we'll talk more about temperature later. Now, electric current, 这个是 I， 这个我们叫它 ampere. Ampere, capital A. One, how many amps? 1 amp. 你的power bank charger 它有写 okay 2.1 amp, 2 amps. Okay, how fast you can charge? The fast charging one 6 amps. That is huge current. Okay, 5 amps. That is electric current. Okay, here we complete already this one. Now then we go to derived quantity. Derived quantity. 第一个 area formula length 乘 length. Okay, length 乘 length. Now base unit 就是这个 length 的 unit 啦。Let's say 我要找 area 的 unit， 我要知道它的 formula 先，然后我把它的这个 formula 换成那个 unit。我的意思就是很像这样子啊 ，area 等于 length 乘 length 对吗？等于 OK， 然后你放 length 的 unit 是什么 ？meter。OK， 我把它换成 unit， 我放一个 m， 再乘一个 m，m 乘 m 你拿到什么 ？m square。所以你的 area 的 unit 是 m square。OK， 我这样子写啊 ，a 等于m 乘 m， 不要这个了，我直接写 m 乘 m 等于 m square。So derived unit is m square. Why do we say derived unit? 因为这个 unit 这个 m square 我从哪里拿来？我从这个两个 m 乘起来，所以我从那边 derive 来的，我叫它 derived unit。这些 unit 是叫什么？这些是 base unit。Okay, base unit， 然后这种就是 derived unit。Okay, next one, volume, L 3次，所以一样咯。你的这个就是你把它换成 unit， 所以 m 乘 m 乘 m 等于 m 3，所以你的 unit 就是 meter cube。OK， density formula 是什么？在你的 junior 3学到什么 ？density mass 除以 volume 对吗 ？mass volume。OK， 把它换成 unit， 因为我要知道 density 的 unit。OK，mass 的 unit 是什么？看上面这边 kg 除以 volume 你已经有了吗？这边 m 3，所以你放 m 3这边。这个是什么来的 ？kg over m 3，你可以把它写成 kg/m 3。OK， 有时候你会看到他们写 kg， 然后 m 放一个减3这边 ，power of -3， 这个跟这个是一样的东西来的。你可以写 /m 3，或者你可以写 m-3。OK， velocity， now velocity 把它当成 speed 呢，我们过后会讲到什么是 velocity，but 我们先当它是 speed，so speed 是等于 distance divided by time。OK， 所以你走多远，你除你的时间，你就拿到你的 speed。 So distance 是什么 ？distance 是 length 啊，它跟 length 一样的，所以它的 unit 是 meter。m time 是 second，所以我放 s m over s m slash s or ms minus 1。这种 unit 是我的 derived quantity 的 unit。所以改次如果你看到他写 question 写30 ms minus 1，这个东西是什么来的？这个东西是 speed。OK， 这个东西是 speed， 所以你看它的 unit， 你可以知道它是什么 quantity。一定要给 unit， 每个 physical quantity 你一定要给 unit。length， 如果你 calculate 的时候到最后你没有写到 unit， 在考试全部他给直接错完。OK， because length, if I say this pen is 7 long, can you understand? This pen is 7 long. What does it mean? But if I say this pen is 7 cm long, then you understand. So physical quantity must come with unit. You cannot forget the unit. Okay, so every time you have this one, 30 ms minus 1, okay, look at the unit. What is this? This is speed. If I say, okay, 如果我写50 kg slash m3, okay, 这个是什么来的？这个是 density. So all this you have to remember 啦。Alright, acceleration 我们割掉先，我们过后我们学到 acceleration， 我们再回来。Okay, so that's all for the physical quantity for now. These 5 you need to remember because sometimes they will ask what are the 5 base quantity. Then you have to be able to give all this 5. Okay, and all this derived. 不只是这边呢，还有很多 derived 的，还有很多 derived quantity. OK， 来，我们来一个short break, and then after that we will come back. I'll give you 5 minutes. You can go and drink water, go to the toilet, anything. We'll take a 5-minute short break, and we come back. We will continue for the next part. OK， 来，我们回来啊。OK， 来，接下来我们看多一个 sub。After I finish this prefix, then it'll be a wrap for today lah. Now, prefix. So as we already understand what is unit, let's take one example. Let's say we have length. So we know the unit is meter, right? This is the base unit, correct? This is the SI unit, and also it is called base unit. Why do we call it base unit? Because it's the base quantity. Okay, this is base quantity. And we don't get meter from anywhere else. It's just meter. Now, this base unit, I can combine with a prefix. For example, if I say 1 million, oops, that's not 1 million. Okay, this is 1 million. 6 zeros, 1 million meter. If I say 1 million meter, in calculation, 我们当然讲在 calculation, this is not efficient because you have to write many zeros, right? So to make it simpler, to make it more sufficient, okay, in the calculation, we will use prefix to kind of make it become smaller, okay, so that we don't need to write that many zero. Okay, for example, this one, we can write it as 1000 kilometer. Okay, you see, I use the kilo so that I only write 1000 kilometer, because when you convert 1000 kilometer, one kilometer is 1000 meter, right? 1 kilometer, you get 1000 meters. So when you times this one, you get the same number. Or I can say 1 mega meter. Okay, 1 megameter. So you can say 1 megameter, 1000 kilometer, or 1 million meter. They are all the same value. You see, what I'm doing here is that I'm adding one letter in front, this one and this one. What is this two thing? This is kilo, this is mega. You have many more. Nano, pico, deci, centi, milli, all this. Tera. Okay, all this, what do we call it? We call it prefix. This one. Okay, prefix. So let me write the prefix out here. First, you have the base unit. Let me just write this line here. This line is the base unit. It has a power of 10, 0, a factor, okay? So going down one line, we have the deci. Deci is 10 minus 1. This is the next line. And we have here centi. Going down is becoming smaller, So centimeter is 10 minus 2. And then we have milli. Milli, we have 10 minus 3. What else? We have micro. Micro means very small, right? Micro. So you get going smaller and smaller. So 10 minus 6. And then we have nano. 10 minus 9. We just do until 9. Okay, that is going down smaller. Now going up, you have first is kilo. Kilo is 10 power of 3, right? So 1 kilometer is 1,000 meter. So you have a factor of 10 power of 3 here. And then we have going up one more, which is 10 power of 6, that is mega. 10 power of 6. And you have giga, right? Giga, 10 power of 9. Okay, so in the storage, megabyte, gigabyte, terabyte, you're already familiar with all of this. So it's going bigger and bigger. So this is the factor of the prefix, and these are all the prefix. In this section, we need to know how to convert from one prefix to another prefix. Let's say I ask, okay, what is 70 micro? Okay, let's do the easy ones first. What is 70 meter to micrometer? How do you convert this? Maybe you're already familiar with cm and meter, right? You know 1 cm is, okay, 1 meter. 1 meter is 100 cm. You're already familiar with all of these, the common ones, but we are not really familiar with the micro, the nano, the tera, the giga, right? So if I ask you to convert 70 meter to micrometer, then how are we going to do the conversion? Okay, you see, here I will teach you a method that if you already know how to do it, you can do any conversion, okay? Any conversion, you can from here, jump there also can. So remember how to do it. So here's the method. You see, first, you need to know going up is bigger. Going down is smaller, okay? That's the first one. Second, you need to know bigger to smaller. Okay, this one everyone knows lah. You know already, bigger to smaller. 大去小，我们做什么？我们乘。小去大 ，smaller to bigger。我们除，这种是定了的，不会换的。OK， so let's say 我们现在从70 meter right？ OK， 你找70 meter 在哪里 ？meter 是它有没有 prefix？ 它没有 prefix 对吗？如果有 prefix， 它前面有一个 letter， 所以它只是 meter 罢了，所以没有 prefix， 所以它是 base， 所以它是在这个中间这边，中间这个线呢 ，10 power of 0。然后我们要去哪里 ？micrometer。What is the prefix? Only look at the prefix micro. This symbol here, okay. Sorry, I forgot to tell you that this symbol is micro. It's micro. Every single prefix has a symbol. Giga 的 symbol 是 capital G， mega 是 capital M， 然后我们有 kilo 小 k，deci 是 D，centi 是 C，milli 是小 m，micro 是这个好像 U 这样子，可是它的耳朵比较长。这个我们叫它什么？叫它 mu， is pronounced as mu， M-I-U, mu. Okay, micro, a Greek letter. Okay, and then here is nano, N. Okay, so all this symbol you need to know. So if I write like NS, 什么鬼是 NS? Let's say 我讲30 NS. 这个 N 是什么？第一个 letter usually is the prefix. The first letter is usually the prefix. The second letter is the unit. Okay, then you look at what prefix is N. Okay, this is nano. What unit is S? That is second. So that is nanosecond. Okay, so if I say 40 mu A, what is this? Okay, the first one is prefix, right? That is micro. How about the second one? The second one is the unit. Look back at the base unit just now. This is current, electric current. Okay, electric current, the unit of the current is ampere, what, right? 1 amp, 2 amp, 3 amp. Okay, so you need to be able to identify this. Right. So after you identify, we are going from meter to micro, right? So we draw an arrow from meter, which is the base, to micro like this. 现在你看，我们是走上还是走下？我们从这边走下去，对吗？所以你从大去小，因为越高是越大，越低是越小。你走下来，从这边我们指下来，我们是从 big to small， 所以 big to small 我们要做什么？我们要乘 ，OK？ 乘什么？我们乘 factor 10 to the power of， 然后那个 power 啊，我们用大减小。OK，again， 我们用大减小，我们有10 power of 0，然后我们另外一个 micro 的 power 是10 power of 减6，哪一个比较大？0还是减6比较大？0比较大 ，because it's closer to 0，right？ 就是讲 -2 and -6， -2 is bigger because it's closer to 0。So 0 is bigger than -6. We will take the bigger minus the smaller. 所以0减。不要忘记那个6也是有一个减呢，减6，所以0减6等于0加6，所以就是6啦。这个做成我们的 power，OK， 这个做成我们的 power， 你只是减那个 power 罢了，我们只是要拿那个大减小是那个 power 罢了。And then 我们做成这个我们的 power， 所以乘10 power of 6。Okay, so from here， 我们把它写成70乘，直接把它放进去了，乘10 power of 6 micrometer. The moment you put the times 10 power of 6, now already become the micrometer. So you have to write here micrometer. This is your answer. Maybe you can put it in standard form, right? So 7 times 10 power of 7 micrometer. This is the standard form of it. Or you can just write 7 and then 70 at the back. Okay, huh? So you have to follow this method. So here, because sometimes students ask, why don't just like multiply 6 every time? If I move to 3, I just multiply 3. If I convert to 9, I just multiply 9. Please don't. Please follow the step, because sometimes the question can give you something like this. I can give you 2 centimeter to gigameter, or I can give you like 2 microsecond to megasecond. These all are going to be a little bit confusing, slightly more confusing. What about I give you square like this, 2 microsecond square to megasecond square? It's getting more and more complicated, right? So to do all this, we stick to one method only, which is the one that I just told you. Okay, now I give you more examples. This is example 1. Let's put it here. Okay. If you can, you take some notes, okay, so that you remember later. All right, let's do example 2. Let's try this time. Let's try, okay, 365 nano s, that's nanosecond, right? Nanosecond. I want to convert to let's try megasecond. Okay, so nanosecond to megasecond. Now, first thing, draw the arrow. Where are we going? We are going from nano to mega, right? So where is nano? Down here. We go up to this one. So we are going from -9 to this 10.6. Okay. Now, before you do anything, it will be easier if you straight away convert this to standard form first. Okay, you'll see what I mean later. 365，我把它换成 standard form 先。所以是什么？3会换 standard form 吗？那个小数点呢？365本来那个小数点是在5的后面对吗？ 所以你把它搬前来3.65，然后你要乘，你不可以只是这样子放3.65，因为如果这样子的话，你已经是换那个 value 了，所以你要乘10 power of 2 to kind of adjust back. Okay, so when you multiply this one, then you get back the 365. Okay, 当你乘这个进去，你拿回这一个一样的 value. Always check 啊，当你 convert standard form，你 check 回去，如果你 expand，你是不是拿回一样的东西 ？So this one is the standard form, nanosecond, right? To megasecond. 我还没有做 conversion 呢，我只是换去 standard form 罢了。OK， 现在我做 conversion。nanosecond 这边走到去上面，所以我乘还是除？下面去上面，我小去大除。OK， 小去大除，除多少 ？OK， 除10 power of 这个 power 怎样找？大减小，我们拿大的 power 6减这个9，所以6减9，6加9 15，所以10 power of 15，这个是除，把它放进去，所以我这边有3.65乘12，然后我的 unit conversion 除10 15。OK， 接下来我做什么？为什么我一来要换去 standard form？ 因为你看这样子，我直接很容易的，我可以 solve 这个12除10 15，10 power of A， 如果你有一个乘10 power of B， 两个的这个我们叫 base 啊，这个是 power 嘛，对不对？这个是 base。如果它的 base 一样，然后它是乘，你可以把它的 power 加起来，10A 加 B。Okay, this one you already know 啊 ，you already know. If the opposite， 如果我写10A 除10B， 然后我可以把它写成10A 减 B。So these two rules are the power rule. OK， 所以你看这边我们可以直接 solve 咯，我们可以直接 solve， 我直接把它写成3.65乘10。我们这边有除嘛，对吗？这个除，所以是2减15。2减15等于3.65乘10减10 13。unit 不要忘记 unit 是 after 你 convert 了，你拿到 megasecond。This is your answer, and already in standard form because you already converted in the first place. So your answer is better if it's in standard form. If there's lagging, you have to let me know. If there's lagging, sometimes the internet not very good. But you can still rewatch the lesson tomorrow. I post the video. If you feel like you missed something. Okay, let me erase this. And oops. And okay, I show you one more. Let's do a few more. Okay, let's try number 3. Let me write it here. Number 3. Let's try 3 okay, 0.005 giga GG to mg. Okay, identify the prefix. 这边我们有 giga， 第一个是 prefix， 第二个是 unit， 所以第一个是 milli， 不是 meter 啊 ，it's not meter 啊，因为这个是 prefix 来的，所以是 milli， 然后 g 是 gram。OK， so gigagram 去 milligram。OK， 所以你要记得你的那个 unit table。Alright, so now we do the conversion. Okay, we've changed standard form first. 0.005把它拉前去，所以5乘，我要做一个 adjustment 乘减3。OK， 因为如果我一 expand 进去，这个小数点去后面3次，我拿到0.00005。Okay, so this is my standard form GG to MG. OK， 接下来我画从这边呢 ，giga 下去milligram， 所以我是从10 power of 9去10 power of 减3，乘还是除？乘咯 ，bigger 去 smaller， 所以乘10 power of 什么 power 这边大减小，9大过减3，所以9减3。减加，所以9加3 12，所以10 power of 12。Okay, times 10 power of 12. So now we put in here 5乘10减3乘10 power of 12，两个是乘，直接把它加起来咯。5乘10减3加12， 5乘10 of 9 unit milligram. That is your answer. Already in standard form. Okay, so any conversion, same method. In the question later, the exercise, I'll give you some exercise later. Any conversion, you use the same method. Or how about square? How about if you want to do square like this? Let's say 30 cm square to nanometer square. How do you do the square one? Okay. 看这边一样的，只是多一个 step 哦，全部东西是一样啊。那你这样子，如果你看到有 square， 你把它当做是 cm 跟 nm 吧先 ，OK， 你把它当做是没有那个 square 的，你把它当做很像 cm 跟 nm 这样子做。So 这个是 centi， 然后这个是 nano， 所以我从 centi 去 nano，OK， 所以我把它画这边 ，OK， 从 centi 这一个下去 nano， 乘还是除 ？Bigger to smaller， 从上面下来，所以是乘。OK， 大去小啊 ，centi 比较大 ，nano 比较小，所以大去小我乘，然后乘10 power of 那个 power 是大减小 ，OK， 拿大的 power 减2比较大，减小的 power 这个是减9，所以减2减9 ，OK， 不要忘记那个减9的减，所以 OK 我写在这边 减2减9，所以是减2加9等于7，所以乘10 power of 7，这个是我要乘的 factor。OK， 所以乘10 power of 7，把它放进来。OK，30乘10 power of 7，对吗 ？OK， 那个30我换去 standard form 先，忘记了。那个30，我这个是可以写成3乘10 power of 1，对吗 ？OK， 如果你忘记讲换 standard form，跟我讲啊，或者你 refer 回去。I assume that you know how to change this to standard form, but if you forgot, then please let me know. Okay, so standard form, and then you put this one in. 刚刚你写到这个乘10 power 7，对吗？所以乘10 power of 7。OK， 那这里就是它的分别。我刚才是照着像 cm 跟 nm 没有 square 这样子来做，对吗？现在如果它有 square 的话，是我要做什么？我只是 square 这个罢了，这样子罢了。其他的东西是一模一样的。我 square 什么？我 square 我的 factor。OK， 不是 square 这一个啊，不是 square 这个，不是 square 这个两个一起。No， 为什么？因为这个是从你的那个 standard form 来的。我只是 square 我的那个要乘的那个 factor， 当我要做那个 conversion， 就是这个10 power of 7 square。如果它是 cube，then 你就 cube 一样的东西。如果它是 cm cube 去 nm cube，then 你这边就是 cube。OK，so you calculate the rest. Okay, 3 times 10 power of 1乘这个 power 乘起来12、7、14。OK， 3乘11乘10 power 14，这个是乘，把它加起来，3乘10 power of 15 nm square。That is your final answer。如果你不会做这个 factor， 你觉得很复杂 ，OK， 这样你直接 type 进 calculator 这个整个东西，它都会给到你这个 final answer。Okay, you still get this 3 times 10 power of 15. So using the same method, you can do any conversion, whether it be square, cube, or even power 4, all of that. From here to here, here to here, you can do all of it using the same method. So please take note for this part. And also don't forget that the previous one, what we just discussed, the standard, the base unit, derived unit, scalar, and vector. Okay, but we will talk about more in the coming lesson for the scalar and the vector.